Okay, so we're now dealing with question 2, and in question 2, what we're told is that we have f of x, which is equal to 1 over 3x minus 1, and we need to find the rule of the inverse function. So how are we going to do this? Well, we simply swap my x and my y, but as you can see, I don't have y here, I have f of x. So my first line of working, I'm simply going to state, let f of x be equal to y, and then I can swap my x and y. So this is really just me telling the examiner what I'm doing, just so I'm not confusing them. All right, so that means I can now swap my x's and y's. So my x is going to be up here, and then I'm now going to have 3y minus 1, and now I'm simply going to rearrange it. So it's going to be 3y minus 1 is equal to 1 over x, and then I can say I have 3y is equal to 1 over x plus 1. I now want to get y by itself, so I'm going to have to get rid of this 3. So I'm going to multiply this side by 1 over 3, and by doing that, they're going to go away. And that means I'm going to have to multiply this whole side by 1 over 3 as well. So that means what my final answer is going to be is the inverse function of f is going to be 1 over 3x plus 1 over 3. Make sure you include this notation. If you didn't, you'll most likely lose a mark. Let's now read the examination report and see where the state went wrong when they were trying to answer this. So as you can see, this was worth 2 marks, and 57% of the state got the full 2 marks. Similar working was used. They simply didn't change the f of x into y, but the same working was there. You can see our answer right there, and there's an alternative way to write it. In their little description here, it says, this question was well attempted, and generally well done. However, in some cases, progression to the correct answer was hindered by errors with algebraic manipulation, transposition, or poor use of notation. I think what they mean by that is people forgot to put in their final answer the inverse function of f of x is equal to this. So let's highlight our answer, and let's now move on to part B. Part B is asking us, what is it asking us to do? To state the inverse function, the domain of the inverse function. So we now need to state the domain of the inverse function. So what you need to know here is that my domain of the inverse function is going to be equal to the range of my original function. So you might like to just quickly draw a little picture of this. So if I was to draw this, here are my axes. Not the neatest thing in the world, but it doesn't need to be. I know it is a hyperbola, and I know that I'm going to have a asymptote where my denominator is equal to 0, so 3x minus 1 is equal to 0. Therefore, x is going to be equal to 1 over 3, so it's going to be here. I also know that I have another asymptote, so let me just write this one down. I'm going to have another asymptote right here at y is equal to 0. Y is equal to 0 is going to be another one, and my graph is going to look like this, Make sure you check out your domain here, which clearly tells us that we have all real numbers excluding 1 over 3, so that's our vertical asymptote right here. So what is my range of this thing going to be? Well, my range is simply going to be all real numbers excluding my horizontal asymptote, which is 0, so all real numbers excluding 0. So now that we know what the range of my original function is going to be, I therefore know what my domain of the inverse will be. So my domain is going to be equal to, let me do this in black, my domain is going to be equal to all real numbers excluding 0. Too easy. Let's now look at the examination report and see how the state went with this question. So if we come over here, you can see that the state went pretty well. 64% of the state got the full 1 mark. Here is the answer that we wrote here. And it says, in general, students knew that the domain of the inverse function was equal to the range of the function. Perfect. All right, so let's now move on to part C. Part C. All right, how are we going to do this? Let's give it a read. It says, let G be the function obtained by applying the transformation T, so this right here, to the function f, where this and C and D is an element of, so C and D are all real numbers, Find the values of C and D given that G is equal to the inverse of F. Okay, so what we're doing is let G be the function obtained by applying the transformation T to the function. So I'm applying this transformation to F of X, and it's going to turn into G of X, G of X. And we know that G of X is equal to the inverse function of F. So what that is going to be is simply this. So we're going from this to this. And we need to figure out what my transformations are going to be. And as you can see, they're both translations. There's no dilations happening here or reflections. It's simply just translations. So let's just bring this down here. That's what we're doing. We're trying to figure out what the transformations are from this to this. There are a couple ways you could do this. There are two ways you could do it. One of it's kind of like the long drawn out way, and the other is by inspection. Let me show you the longer way first. So I know what my f of x is. It's y is equal to 1 over 3x minus 1, and that is being transformed into this right here. So my inverse function was y is equal to 1 over 3x plus 1 over 3. Okay. Next, I would come and I would look at my matrices here, and I know what this is telling me is that my new x dash, is going to be x plus c, and my new y position, y dash, is going to be equal to y plus d. So x dash and y dash is my new point. So it's obviously going to lie on my newly transformed graph. So let me put in those right there. So I have y dash, x dash there. Now what I'm going to do is do a bit of rearranging. So this is going to stay the same on this side. But then when I come over to this side right here, I can rewrite this. I'm going to bring this over to the other side because this is affecting my y. So it's going to be y dash minus 1 over 3 is equal to 1 over 3x dash. The next thing that I'm going to do is set things equal to each other. So I'm going to set my y equal to this right here. And I'm going to set this equal to that. All right, so that means I'm going to get y is equal to y dash minus 1 over 3, and I'm going to get 3x minus 1. 3x minus 1 is equal to 3x dash. Now what I'm going to do is rearrange it so I have it being equal to a y dash. So that means I'm going to get y is equal to y dash equals y plus 1 over 3. And then over on this side, what I'm going to get is my x dash is equal to 3x minus 1 over 3. And I would then rewrite this. I can rewrite this like this, 3x over 3 minus 1 over 3. And obviously, this and this are just going to cancel, which means I'm just going to be left with my x here. So my x dash is equal to x minus 1 over 3. And as you can see now, let me just zoom out a little bit and let's just reflect on what we've done. I have created this, but down here. So as you can see, my y dash is equal to y plus d, and here I have y dash is equal to y plus 1 over 3. So it's quite clear that my d value here is simply going to be 1 over 3. So my d value is going to be equal to 1 over 3. And then I would do the same for this right here. So I have x dash is equal to x plus c. And here I have x dash is equal to x minus 1 over 3, which means that my c value, let me get my red pen, my c value is simply going to be negative 1 over 3. So I come over here and I'm going to go c is equal to negative 1 over 3. And that right there is going to be my answer. Let's now look at the examiner's report and see how people fared with this question. And as you can see, I've spent a bit longer on this one because it was not well done by the state. 24% of the state got the full 1 mark for it. So, as you can see, C is equal to negative 1 over 3 and D is equal to 1 over 3. So that's what we got here. It says this question, let me get a smaller highlighter. It says this question, while well attempted, was not well done. Some students had the incorrect sign for C and D. Other students attempted dilations rather than the translations as specified by the question. Okay, so not well done, and you might be thinking to yourself, wow, you've shown all this working out, but it was only worth 1 mark. Is there a quicker way you could do it? And there absolutely is a quicker way you can do this. You could do it by inspection. If you do it by inspection, you do run the risk of making a silly error, which it seems some people from the state did. Well, a majority rather from the state did. I'll show you that method, but it's really important to know that you can rely on this method, and this one will, never lead you wrong. Okay, so how could we do this another way? So the other way we would do this is doing it by inspection. So let me just kind of clean this up a little bit. Let me move this over here, like this, like this. All right, so if we were to do this by inspection, so what does that mean? I'm gonna do it by inspection. So I'm starting with y is equal to 1 over 3x minus 1, and that is turning into y is equal to 1 over 3x plus 1 over 3. Well, knowing this, what we could say is that I could rewrite this. I could rewrite this as 1 over 3x minus 1 over 3. And that is being turned into simply what we have here. So let me just copy that down. Now that I have it written in this form, it's quite clear what's going on. We could even give it a quick sketch just so you are all on the same page. So if these are my axes, it's quite clear that I'm going to have an asymptote right here at x equals 1 over 3. X equals 1 over 3. So that means this has been shifted to the right 1 over 3 from my original, starting at the origin there, it's been shifted. This one, on the other hand, if we were to look here, and let's just come over here really quickly, and again, I'm slowly talking through this, but this is something that if you were to do it this way, you just have to kind of recognize it quite quickly. Right here, what is my asymptote? Well, my asymptote is simply going to be where this is equal to 0, so 3x equals 0. Well, x is just going to be right here. X is going to be equal to 0, so that is where my asymptote is going to be. So as you can see, it's just been shifted back this way. If I just shift it back that way, I'm going to achieve my end. And so what that means is that my C value here is going to be negative 1 over 3 because I'm shifting it to the left. And then simply I have 1 over 3 here, and there isn't any vertical translation here. So obviously my D is just going to be shifted 1 over 3 up. And you'd be done. That's how you'd get your D value. So immediately recognizing, well, I have this plus 1 over 3, so that's shifting it 1/3 up. And I have this x minus 1 over 3. So if I want to get it back to the origin, I'm going to have to make my C equal to negative 1 over 3. People get confused with this because the question then arrives, well, which one's, especially with the x, the sign with the x, and the examination report makes note of that people had the incorrect sign for C and D. But I imagine the real problem people had was recognizing that the C was negative, and because I'm putting it into this form and because I'm moving it to the left, it's going to be negative 1 over 3. That's why you have to be careful doing this, and sometimes it's just safer to take a few more minutes and do it this way if you are unsure. But you also have to keep in mind that time is a factor, and it is only 1 mark, so I really think they expected you to do it in that way. The examination report also makes mention of the fact that students attempted dilations rather than the translations as specified by the questions. So some students thought that transforming this to this involved a dilation, but in fact that isn't the case. And the way we know that isn't the case is because in front of both of my x's is a 3. So I have a 3 there and I have a 3 there. So too over here, I have a 3 in front of my x, and I have a 3 in front of my x, and that means that both graphs have been dilated 1/3 from my y-axis. So that means a dilation is not separating these two graphs, and therefore would not have to be applied to turn one into another. Because I think this is something that people may get confused of. I've just included this little sentence here, which I'll include, and it says, no dilation is occurring in the transformation from f of x to the inverse of f of x. This is because both f of x and the inverse of f of x has a coefficient of 3 in front of the x. This means both are dilated by a factor of 1/3 from the y-axis, thus only translations separate f of x from the inverse of f of x. And that's also too obvious by what the question tells us itself. The question tells us that we're only applying translations, so there is absolutely no reason why any dilation should have been occurred. It tells you, the question has specified that translations are occurring, no dilations. So I just wanted to make mention of that as well. And with that being said, I think I've covered everything. With this one, I did spend a lot of time with it, and that's because only 24% of the state got it right. Okay, so there is everything for question 2. Hopefully this has been helpful, and I'll see you in the next video.